Hey, welcome to the shop. We're building a new cart for the MIG welder day. The one it's been sitting on is super rickety. I mean, it won't even roll over a zip tie, and we got to do better than that around here. So we're gonna build our own, and I designed this to be as simple as possible, to use only a few different types of materials so it'll stay economical. And I put together a full set of detailed plans with material lists, step-by-step instructions, dimension drawings, everything that you need to build this yourself. That's on my website, so you'll find that link in the description if you want to build one of these yourself. So the cart we're building is going to be pretty similar to this that I built for my TIG welder several years ago. It's been nice because it has the big wheels that are easy to roll. It's all welded so it doesn't rattle around. But I don't like these hooks and a few other things about the way that it's built, and so I'm going to improve those this time. So these are the wheels I'm using. They're just from Harbor Freight. This is their 10-inch solid rubber wheel. I've never wished that I had a smaller wheel on a cart, so I just go with the big one. And then I played with the casters until I found one where the top plate here would be even with the top of the axle like that. And these 4-inch swivel casters fit pretty good. I could have drawn this up on paper, but I modeled it in Fusion 360 so I'd know exactly what I'm going to be building, and I could create the drawings for the plans on my website. And I decided to order a few parts from Send Cut Send to make the process a little bit easier. Now, these aren't so complicated that I couldn't cut them out by hand, and I've included both drawings to cut them out by hand or DXFs to order them here, cut them on a plasma table. This is going to save me quite a bit of time. It's $65 if you get everything with the 15% discount, or about $35 if you just get the essential parts and weld the casters directly on. I'll begin by cutting the square tubing for the upper and lower tiers of the cart, and I'm going to use this EvoMax saw from Evolution. I've been loving this shadow line feature that it has. Honestly, even though I have their mitering chop saw, when I'm just cutting square tubing like this, I think the single clamp on a regular chop saw is a little bit faster, so I tend to go towards that, but both of them work really well. Now, I'm going to lay them all out like this, so you can see there's a rectangle for the top and the bottom, and then a cross piece for each. With the first one, I'll be using my Siegmund table and all the fixturing there, but I'm also going to make the second one just old school, so you can see how to do that if you don't have a fixture table, which I didn't for many years, and that's just fine. Then we'll compare the actual flatness that we got with the two different methods. So with the fixture table, the main thing that I always do is get a square reference with stops like this, because if you can get two pieces in there square, the rest just kind of falls into place as long as you get everything parallel. So I'll clamp all of the parts down, make sure that they're all square, and I'm good to go ahead and tack and weld it. Now, honestly, with it clamped down like this, I could just weld the faces of all these joints without tacking, but I like to tack it up first just to keep everything in place, and then weld from the inside to outside, even though it doesn't matter too much with it all fixtured. It's just a good practice from a sequencing perspective, and it's going to matter a lot more when we weld the next one free. Now, there is some face reinforcement there that I'm going to grind off. I would leave those, except that I need the shelf to sit on it and the casters on the other side. So I'm going to go ahead and just grind it flush right now, and then flip this part over to weld the other side. Now on the back side, I'll weld the faces also, and see, as you work your way through a structure, it gets locked in a little bit more every step of the way, and so that helps with distortion. Now I'm welding the inside verticals downward. Anything up to about 1/8 of an inch you can weld down in a single pass, and it works out just fine. You can get good penetration with it. When you get thicker than that, that's when you need to worry about going uphill. Same thing on the outside corners. For weld sequencing and distortion, the corners don't do much, so I just left them till last. You could have done them earlier. But I'll check for square by measuring the diagonals, and I found them to be within 1/16 of an inch, so I'll call that good enough for the cart. Now to check it for flat, I'm going to use these 1/2-inch thick shim spacers, and then put one under each, because I don't want the welded or ground areas to actually be affecting it. So I'm going to lock down one corner that it wobbles, so all of the slop is in one side. And so I'll check, and a 5 thou feeler gauge can go through, but a 10 thou feeler gauge can't. So it's pretty flat. I'd call that a win for sure. So somewhere between 5 and 10 thou. Now let's put together the next one old school.
So I'm going to start off with a square, and the issue you have a lot of times is that joint can slide between one another. So if you draw a line, usually at the center, or at least at a known distance in from the outside, that can allow you to line everything up. Because if you get this right, the rest of it goes much better. This is where you can really chase your tail if that is slid off a little bit, because it'll still show square. So if you get those in place, hold it with a square, and these cuts are really good, so it's sitting pretty parallel, but if one side is touching and the other is not, always tack on the side that's touching, and that lets you move it around and square everything up once you get it in place. So I did the same thing on the other corner and then up on the top side. Now on the top side, the main thing I'm looking for right now is that they're parallel more than them being square, because we can square it up a little bit later. So once they're sitting parallel here, I can go ahead and just put one more tack on each side. Now you can see this takes quite a bit longer to check and work your way through than if I were using the fixture table features. But I just wanted to show that you can do this and do a good job of it, even if you don't have a fancy fixture table like this. So once I have everything parallel, I can just check for square and lock it in place, because these tacks aren't really going to pull that much, at least at this point on this thin material. Now if you're fabricating with thicker stuff and you have heavier welds, you're going to have a harder time getting away with just doing it free on the bench. But on this thinner tubing, I've had pretty good success at getting things to lay square. It's just a matter of getting it all tacked in place and then your weld sequencing. So notice I'm welding from the inside to the outside, and I blew a hole right there. Doesn't happen very often anymore, but every now and again if I'm not paying attention, so I'll just tack to fill that in and carry on. So if that happens to you, don't feel too bad about it. Just fix it up and carry on. Now we'll weld the rest of these parts together right here and flip it over and weld the other faces. And once you have the faces welded, it's locked in place pretty well. Now another advantage of welding those inside corners vertical down is that you're not going to have as much distortion. Now here I'm feeling which direction it rocks, and just like the other side, I'll clamp down one of the corners, so all of that variation is in the other, and once again between 5 and 10 thousandths of an inch. So it's really just as flat in this case.
The main frame components are done, the upper tier right here. So the welding machine will sit on a piece of sheet metal that's going to go in here. This is a handle to move it around, and it sits right over another shelf that'll go on the lower tier right here, and then your gas cylinder sits there. So as far as the hooks go, I'm going to do something similar to this cart that I built a few years ago. I put these round plates on here so they don't get caught on things, and that's been really good, and it's a nice place to be able to keep the leads. I've modified the concept a little bit this time with a different shape and using common material, but this is the idea I'm using.
It'll be easiest to weld the hooks right onto the upper tier now before I assemble the cart, so that I can just lay them out here on the bench. I ordered the plates in that Send Cut Send pack.
So these are the laser cut parts that I ordered. None of them are so complex that I couldn't have cut them out myself, and I would have saved a little bit of money by doing that, but it would have taken a lot longer than most people think to get all of these shapes cut out right, to drill and tap the holes, things like that.
Now, even with the nice laser cut edge, I'm going to break the corner just a little bit because my leads will be hanging on here and I don't want it to dig into them. So I'll just soften it on the belt grinder. I built this, by the way, a while back. It's been really good. I used it a lot in the shop. So you'll notice that one of these plates is long, and that's because for my MIG lead, or if I were using this for a TIG welder or plasma cutter, the main lead, I don't want to wrap quite as tightly. I want it going over two different posts. So that's why one is long, and then there are 4 short ones, which just gives me enough for a stick lead and work clamp, the power cord, and just plenty of extra things. I need to add 4 uprights to join the upper and lower tier together, so I'm just going to put a tack, and you put that on the long edge if it's not quite square. These are pretty square, but then I can move it around to square everything up. So 1 tack on each of the pieces, and then I'll put 1 tack on each piece once I put the top on, and that'll give me the flexibility that I need to be able to square it up to best condition. Now, if you are a beginner, don't worry if it doesn't quite square up perfectly. It'll still work pretty good for you. In my case, because things were cut pretty precisely, it squared up really well. And so once you get everything tacked up, you can just weld it out, and that'll be good to go. It's really nice just the simplicity of having those hooks right off the upper tier, but that can be problematic. See, my door opens down, and so it's fine. But if your wire feeder door opens upwards, it can bump into those hooks, so you might need to put them lower. So I have an alternate design in the plans where you can put just another runner in to drop those hooks down lower. So keep that in mind. Let's go ahead and cut the shelves out here. Now I could have had these done by Send Cut Send, but it's just a couple simple straight cuts, so I'm going to cut them out by hand, and then I need to notch the lower shelf, which is a great job for the bandsaw. You could do all of this with an angle grinder and a cutoff wheel. It would take just a little bit longer, but you could do a nice job of it, or a circular saw actually works pretty well, or a jigsaw there for those corners. So there are a lot of different options. Now I'm not going to weld the whole shelf, I'm just putting intermittent welds, and I like to mark them out here. It doesn't really matter. I mean, even a couple of tacks would be fine for this structurally, but I just think it's good craftsmanship to mark everything out so that it's nice and even after you paint it. So with the lower shelf welded in, I can add the upper shelf right here. And once again, just one weld in the center and a little bit on each corner is plenty for this. So now I can flip it over to put that cylinder shelf on, and I'm putting the cylinder shelf on the bottom because it creates a little pocket for the actual bottom of the cylinder to sit in when you set it in place. And I really like that, having just that extra little bit of security holding the bottom in place there. And then this is going to sit right on the axle, which will stiffen it. So these are the cylinder mounts, and I had them cut by Send Cut Send. They came out really nice. It'd be really hard to get this level of quality cutting them by hand, but I do have in the plans a one-to-one template that you can cut out of paper and trace on if you wanted to cut them out by hand. You definitely could. Let's go ahead and make the axle out of some 5/8 inch round bar, and just to clean up the corner a little bit, just for good craftsmanship. Now I need to drill a hole for the retaining cotter pin, and I'm using some anchor lube here. This has become my go-to cutting fluid. It's water-based, so you have a really easy cleanup. It stays where you put it, especially when you're tapping, and it's just been really good. So that's kind of my go-to. Once again on the axle, I'm just using 3 lengths of weld, one at each end, and then one in the center to hold it in place. And that'll help support that cylinder right there.
Now if the cart's still upside down, I got the axle mounted for the rear wheels in the back. Up here is where these casters are gonna sit. Now the easy way to do it would be to just weld the casters right to the cart, but I want them to be removable. So I got these plates as part of that Send Cut Send package that I'm going to attach here to be able to bolt the casters directly to, and I think that'll work really nicely. Before I do that, I need to drill out beneath this hole here to give clearance for the fastener. Spin for a little dimple, add some sauce, and let it rip. All right, well, all the fabrication's done. You know, there's actually quite a bit of cutting, fitting, and welding on a little project like this. And for a beginner, it gives a lot of really good practice while still giving you something useful, but the stakes are pretty low. Even if this came out kind of wonky, it would still work just fine. So I think it's really good for that. Now, before I throw some paint on here, I just like to feel around a project for any sharp edges and hit those with either a hand file or a little grinder and clean everything up and make sure I'm happy with it. All right, well, the paint's dry. Really happy with how this is turning out. Let's go ahead and get some wheels on it.
So let me just give you a rundown of the project cost here. So the steel itself was $60 from my local steel yard. That's for the sheet metal, the tubing, as well as the round bar for the axle. The wheels from Harbor Freight were $35, and I got the bigger ones. And the stuff from the hardware store, including the paint, was $20 for screws, paint, and everything. So that puts you right at $115. Now, the send cut send parts were optional. They were about $65 with a 15% discount you can find in the description. And you could spend half that if you didn't get the caster plate. So that'd be completely up to you. But I think it's worth it for a great project. It's really fun to build, and it's going to be really nice in the shop. Be sure to check out the links in the description for the plans and other tools I used, and we'll see you next time.